if we want to identify local maximums and minimums, absolute maximums and minimums, and intervals of increasing, decreasing, and constant from a function, it can be helpful to graph it on our graphing calculator. So let's look at this example. Let's look at x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared minus 1. And let's go ahead and put that into our graphing calculator. All right, so I'm going to go ahead and enter that equation in my graphing calculator. And again, here's your x key right here. So we're going to do x to the 5th, and then make sure that you use your right arrow key so that you're not still up in the superscript. And then you can do plus 5x to the 4th. Use your right arrow key to get out of the superscript. And then plus 10x to the 3rd, right arrow key. And then plus 10x to the 2nd, right arrow, and then minus 1. Okay, so once we have that equation entered, when I graph, I usually start with a zoom 6. The zoom 6 is zoom standard. That is 10s all the way around. So positive and negative 10 on the horizontal and vertical axes. All right, so as soon as I choose zoom number 6, it's going to go ahead and graph. And then once I have that window set, next time I wanted to graph, I would just hit my graph button. So I'm going to choose number 6. You can see there's the 10s all the way around, and there's my graph. Now, I really don't need all this excess over here, and I even don't need some of this over here. I really want to keep seeing all those y values though. So you can change what you see on your calculator any way you want to. I'm going to go to Window, and you can see there are the negative 10 to positive 10 for x and y. I'm going to tell it that for my x values, I really only need to see maybe from like negative 5 to positive 3. So just tell it that. So I can say, okay, I want to see from negative 5 to positive 3, and it's counting by ones. That's fine. That's what the scale is. And then I'm going to leave my y values alone. So now when I go back to graph, now I have an even clearer picture of that graph. All right. So I know that my graph is increasing here, decreasing here, and increasing here. I'm just not sure, when my graph changes from increasing to decreasing, that's a relative or a local maximum. I think that's at positive 2, and I think that maybe that's at 7, but I'm really not sure. Well, there is a feature on my calculator that will tell me precisely what that point is. And the way I do that is I go to Second Trace. So I'm trying to access this Calculate menu right here, and since it's in blue, I do Second Trace to get to that Calculate menu. And then you can see down here maximum and minimum. So since this was a maximum, I'm going to choose maximum. Now, there can be more than one maximum on your graph, and so it wants you to tell it where to look. And so you'll notice it's asking for a left boundary. So I think my maximum is about right here. That's about as close as I can get to it, I guess. And so I'm going to go a little bit to the left of that and hit enter. Now it's asking me for a right boundary. So again, I think my maximum's right around here, so I'm going to go a little bit to the right of that and hit enter. So my calculator will now only look between those two arrowheads within that region for the maximum. So I'm going to go back and guess that I think my maximum is about right here, and it will tell me precisely my maximum is at negative 2.7. Now, it is not really at negative 2.000001. It really is at negative 2, but there are some limitations on your calculator. If you were rounding that off to several places of decimal point accuracy, you would still just get -2. So don't be worried about that. All right, so now that means my graph is increasing from -infinity to -2. It's decreasing from -2 to, I think this is 0. We're going to confirm that in a second. And then it's increasing from 0 to infinity. All right, I also know that because my graph changed from increasing to decreasing, I have a relative maximum right there at -2.7. All right, so now let's go check out this relative minimum. Because my graph is changing from decreasing to increasing, I know there's a relative minimum there. I just need to go find out what it is. So I'm going to go back to second trace, and this time I'm going to choose minimum. All right, so again, I think my minimum is about right here. So I'm going to give it a left boundary by going a little bit to the left and hitting enter, and a right boundary by going to the right and hitting enter. And then I will go back to about where I think it is and enter my guess. And I get 0, -1. Now, this craziness right here, this is the calculator's version of scientific notation. So this is -2.92 times 10 to the -7. What does that mean? That literally means your decimal is going to move to the left 7 places. That means there are 6 zeros in front of this too. So that is 0.00000292. So, of course, if you rounded that to a couple of decimal places, that would be 0. So don't let that confuse you. You would not write this as your answer. Your ordered pair there is 0, -1, and that is your relative minimum. Now, do you have an absolute maximum? Well, because my graph keeps going to infinity, I don't have an absolute maximum, and because it keeps going to -infinity, I do not have an absolute minimum. If, however, I had an endpoint, like if my graph genuinely stopped right there, and my graph genuinely stopped right there, if I had endpoints, then yes, I would have an absolute maximum of this value and an absolute minimum of this value.